From the ethereal strains of a symphony to the gentle whisper of wind through trees, our world is alive with sound. But have you ever stopped to consider the intricate mechanisms that allow us to perceive this auditory tapestry? These strange little sound-catching organs are far more incredible than they look. We often take our ears for granted, these fleshy appendages on either side of our heads. But within those delicate structures lies a world of wonder, a symphony of biological engineering that rivals the most sophisticated instruments ever conceived. Let's explore 10 mind-blowing facts about ears that will leave you speechless. The human ear is a marvel of biological engineering, crucial for our sense of balance. Deep within lies the vestibular system, a labyrinth of fluid-filled canals. Tiny hair cells send signals to the brain as fluid shifts. These signals help us maintain our equilibrium. Whether walking, running, or standing, our inner ears keep us balanced. Our ears are tireless sentinels, constantly bombarded by sound, even in the stillness of the night. Unlike our eyes, which shut off visual input, our ears never truly sleep. They remain vigilant, picking up the faintest whispers and distant rumbles. Our brains filter and prioritize sensory input, ensuring we can sleep peacefully. Only when a sound reaches a certain threshold does our brain rouse us. This interplay ensures we are never truly cut off from the world, even in sleep. The human body is a marvel of self-sufficiency, equipped with an array of mechanisms that keep it functioning optimally. One such marvel is the self-cleaning ability of our ears. Earwax, that yellowish substance we often view with disdain, is in fact a vital component of our auditory hygiene. Produced by glands within the ear canal, earwax serves as a protective barrier, trapping dust, dirt, and other foreign particles, preventing them from reaching the delicate structures of the inner ear. But earwax is not merely a sticky trap, it possesses remarkable self-regulating properties. The lining of the ear canal is covered in tiny hairs called cilia, which move in a wave-like motion, gradually propelling the earwax along with its trapped debris outwards, where it eventually flakes off or is washed away. This ingenious self-cleaning system ensures that our ears remain free from obstruction, allowing sound waves to travel unimpeded to the eardrum. Chapter 4. Hidden deep within the confines of the middle ear, behind the eardrum, lies a trio of bones so small they could rest comfortably on the tip of your finger. These are the ossicles, the smallest bones in the human body, the malleus, the incus, and the stapes. Don't let their size fool you. These minute bones play a crucial role in our ability to hear. When sound waves strike the eardrum, they cause it to vibrate. These vibrations are then transmitted to the ossicles, which act as a lever system, amplifying the sound waves before they reach the inner ear. The stapes, the smallest of the three, is a marvel of miniature engineering. Shaped like a stirrup, it transmits the amplified vibrations to the oval window, a membrane-covered opening that connects the middle ear to the fluid-filled cochlea of the inner ear. These tiny bones, a testament to the exquisite precision of nature's design, are essential for our ability to perceive the world of sound. Chapter 5. Have you ever encountered someone who can wiggle their ears seemingly at will? This curious ability, while seemingly inconsequential, offers a fascinating glimpse into our evolutionary past. The muscles that control ear movement, known as the auricular muscles, are remnants of a time when our distant ancestors relied on their acute hearing for survival. These muscles, more developed in mammals like cats and dogs, allowed our ancestors to swivel their ears independently of their heads, to pinpoint the source of a sound, be it a predator or prey. As humans evolved, relying more on vision and less on acute hearing, the auricular muscles became less pronounced, their function diminished to a mere vestigial quirk. So, the next time you encounter an ear wiggler, marvel at this curious remnant of our evolutionary journey, a reminder of our deep connection to the animal kingdom. Chapter 6. While most parts of our body reach their full size in early adulthood, our ears are an exception. These remarkable organs continue to grow throughout our lives, albeit at a very slow pace. This continuous growth is primarily attributed to changes in the cartilage, the flexible tissue that makes up the outer ear. As we age, the cartilage loses its elasticity and begins to sag, giving the ears a longer, more prominent appearance. Gravity also plays a role in this gradual elongation, pulling on the earlobes over time. So, while our ears may not grow at the same rate as they did in our youth, they continue to evolve throughout our lives, a subtle reminder of the passage of time. Chapter 7. Ears, Pressure Sensing Wonders. Have you ever experienced that peculiar popping sensation in your ears while flying or driving up a mountain? This phenomenon is a testament to the remarkable pressure-sensing abilities of our ears. The eustachian tube, a narrow passageway connecting the middle ear to the back of the throat, plays a crucial role in regulating air pressure within the middle ear. When there is a sudden change in external air pressure, as experienced during ascent or descent, the eustachian tube opens, allowing air to flow in or out of the middle ear, equalizing the pressure on either side of the eardrum. This pressure equalization is essential for preventing damage to the delicate eardrum, which can rupture if subjected to significant pressure differences. So, the next time your ears pop, remember that it's simply your body's way of protecting your hearing from the effects of changing air pressure. Chapter 8. Left ear, right ear, a tale of two hemispheres. While we perceive our ears as a symmetrical pair, each ear plays a slightly different role in processing sound. This asymmetry is rooted in the lateralization of our brains, the division of labor between the left and right hemispheres. The left ear, connected to the right hemisphere of the brain, exhibits a greater sensitivity to music, emotions, and environmental sounds. It is the ear that picks up on the nuances of a melody, the subtle inflections in a loved one's voice, the soothing rhythm of ocean waves. The right ear, connected to the left hemisphere, excels in processing language and speech. It is the ear that helps us decipher the complexities of human conversation, to understand the meaning behind words, to follow the thread of a story. This fascinating division of auditory labor highlights the remarkable specialization within our brains, allowing us to process a vast range of auditory information with remarkable efficiency. Chapter 9. Hearing the unheard, the sensitivity of silence. In the hushed stillness of a soundproof room, devoid of the constant hum of the outside world, our ears become remarkably sensitive, capable of detecting the faintest of sounds we would normally never notice. Deprived of external auditory stimuli, our brains become acutely aware of the internal symphony of our bodies. We become aware of the gentle whoosh of our own blood coursing through our veins, the rhythmic beating of our hearts, the subtle creaking of our joints. Even the minuscule movements of our eyeballs as we scan our surroundings generate tiny vibrations that can be picked up by our hypersensitive ears. This phenomenon, known as otoacoustic emissions, is a testament to the extraordinary sensitivity of our auditory system. So the next time you find yourself in a moment of profound silence, take a moment to listen to the symphony of your own body, a testament to the wonders of our biological design. Chapter 10. Ears, a world of diversity. The animal kingdom is a testament to the incredible diversity of life on Earth, and the auditory systems of animals are no exception. While humans may marvel at the complexity of their own ears, the animal kingdom offers a dazzling array of auditory adaptations, each finely tuned to the specific needs of its owner. Consider the bat, its nocturnal world navigated by echolocation, emitting high-pitched sounds and using the echoes to map its surroundings, to hunt prey, to avoid obstacles in complete darkness. Or the owl, its asymmetrical ear placement, allowing it to pinpoint the location of prey with astonishing accuracy, its silent flight a testament to the stealth afforded by its specialized feathers. Even the humble cricket, its ears located not on its head but on its front legs, picks up vibrations through the ground, a testament to the ingenuity of nature's design. Outro, the symphony of sound. From the tiniest bones to the complex interplay of brain and ear, the human auditory system is a marvel of biological engineering. It allows us to experience the world in all its sonic richness, to connect with others through the spoken word, to find solace in the beauty of music. So, the next time you hear a bird singing, a child laughing, or a symphony soaring, take a moment to appreciate the intricate mechanisms that make this auditory tapestry possible. Your ears, far more than mere sound catchers, are gateways to a world of wonder. Please like and subscribe to explore more wonders of the natural world.